All right, today we're diving into one of the most common and honestly one of the most dangerous flaws on the web, broken function level authorization. You'll hear it called BFLA. We're going to explore what happens when an application knows exactly who you are, but has absolutely no idea what you're actually allowed to do. So let's get right into it.
I want you to just think about this for a second. Imagine you log into an app. It knows your name, it knows your email. It's totally confident that you're a valid user. But what if that's where the checks stop? What if it has no concept of your limits? What if it can't tell the difference between a regular customer and, say, the system administrator? Well, that's the core question right at the heart of the vulnerability we're breaking down today. So let's put a name to it. What exactly is BFLA? Well, it's a critical security gap where a system correctly identifies who you are, but then totally forgets to check what you're supposed to be able to do. To put it really simply, BFLA happens when an app never stops to ask, hey, is this user actually allowed to do this before it runs a command? The system sees you're logged in, which is great, but it doesn't bother to check if you have the permission to, delete another person's account or maybe access the admin settings. And that mistake highlights a really fundamental concept you've got to understand in security. Okay, and this right here, this is where we clear up something that trips a lot of people up. You have authentication and you have authorization. Think of it like this. Authentication is like showing your ID to the bouncer at a club. You're just proving you are who you say you are. But authorization, that's what happens next. That's the bouncer checking the VIP list to see which rooms you're allowed into. FLA is a complete failure of that second step, authorization. The bouncer just lets you wander anywhere you want. Now, to really get a feel for this, let's walk through how an attack actually works. It's surprisingly simple. We're going to see how a completely normal user with zero special privileges can exploit one of these BFLA flaws and basically give themselves the powers of an admin. So let's picture a simple food delivery app. It's got two basic roles. You've got your user, right? They can look at menus, they can order food, pretty standard. But then you've got the admin, and they have all the power. They can add new restaurants, manage existing ones, and even delete them. These two worlds are supposed to be kept totally separate. Okay, so when a regular user is using the app, all they see are buttons for ordering food. And behind the scenes, clicking those buttons calls an API endpoint, something like API/order. But here's the thing. Somewhere on that exact same server, the code for all the admin functions is just sitting there. That includes a much more dangerous endpoint, like API/admin/delete restaurant. The user's app doesn't have a button for it, but the function exists. It's live on the server, just waiting. So here's how the attack goes down. A clever attacker doesn't need a button. They can use really simple tools to craft their own request and send it directly to that hidden admin endpoint. And this is the critical moment of failure. The backend server gets the request, sees it's from a logged-in user, and just trusts it. It never stops to check if the user's role is admin. And just like that, boom, a restaurant gets deleted by someone who should have never, ever had that power. You know, deleting a fake restaurant in our little example is one thing. But in the real world, this seemingly simple bug can have absolutely devastating consequences. This isn't a minor issue, it's a critical threat. The fallout from a successful BFLA attack can be massive. We're talking about privilege escalation, where a regular user suddenly has the keys to the kingdom. It can lead to unauthorized data deletion, or worse, modification of sensitive data. It can enable financial fraud, full-on account takeovers, and in the worst-case scenarios, it could even compromise the entire server infrastructure. And listen, this isn't just theoretical stuff we're talking about. Security researchers find these kinds of flaws in major household name applications all the time. Just take this real-world example from a massive ride-sharing company. I mean, just let that sink in for a minute. A regular person who is just a rider could find a hidden API endpoint, send a request to it, and instantly become a verified driver on the platform. This meant they could completely skip all the crucial safety protocols and background checks. That's the real-world power of a BFLA exploit. It's terrifying, really. And this was not some one-off thing. This exact pattern of vulnerability has been found and patched in some of the biggest platforms you can think of. Social media giants like Facebook, e-commerce platforms like Shopify, and even inside banking applications. Nobody is immune to this kind of mistake. So, knowing just how dangerous this is, how do attackers, or the good guys, the security researchers, how do they actually find these flaws? Let's switch gears for a bit and look at the playbook they use, because understanding their methods is really the first step to building a solid defense. So the first thing an attacker does
They just watch. They open up the developer tools in their browser and they inspect all the network traffic flowing back and forth between the app and the server. They're basically hunting for clues, looking for API calls that have interesting keywords like admin, internal, or maybe different version numbers like V2. Once they find a promising target, they start poking at it. They'll try to manipulate the requests, maybe change their user ID to someone else's, or see if they can just add role equals admin to the request. It's a methodical process of probing the system's defenses to see where the cracks are.
All right, we've seen the attack. We've looked inside the attacker's mindset. Now for the most important part. How do we stop this from happening? Let's talk about building strong, robust defenses against BFLA.
If you remember one single thing from this whole explainer, please let it be this. The golden rule is to never, ever trust the front end. Just because a button is hidden from a user's view in the web interface doesn't mean a thing. That offers zero security. All of your critical security checks must happen on the back-end server. The server has to be your single source of truth. So what does that actually look like in practice? Well, it means that for every single request that hits your server, you have to run a permission check. No exceptions. It means you need a clear system of roles like user and admin, and you enforce them rigorously. It's also a really good idea to have one centralized place for these checks, like in middleware, so you don't forget to add it somewhere. And critically, your system's default stance should be to deny everything. Nobody gets to do anything unless you explicitly write a rule that gives them permission. Just look at the difference here. On the left, you've got the vulnerable code. It gets a command to delete a user, and it just does it. No questions asked. But the secure code on the right, it stops. It asks a crucial question first. Is this user's role not an admin? And if the answer is yes, it immediately shuts the request down with a forbidden error. Only if that check passes does it ever proceed to the delete function. That one simple if statement, that's the entire defense. And that really brings us to the key takeaway. Whether you're a developer building an application or a security researcher who's testing one, the fundamental question you have to constantly ask yourself is this: can I do things I shouldn't be allowed to do? If you can get to an admin page while you're logged in as a regular user, or edit someone else's profile, you've probably just found a BFLA vulnerability. It's a powerful way of thinking that cuts right to the very heart of what authorization security is all about.